Hi, hello everyone. Welcome back to Akki-Vikki. This is Akshaya, 6th grade. In this session, we will do the chapter 11 of NCERT class 10. Find the area of the sector of a circle with radius 4 cm and of angle 30 degrees. So, what is the sector? Is a shaded area like this one. And what is the area of that sector? So, let us write that. For 360 degrees, which is the whole circle, the area is pi r square. So, for 360 degrees, it is pi r square. We have to find for p degrees. For p degrees, it is how much? So if the angle decreases, then the area is also decreasing. But if the angle increases, the area will also increase. Which means these two quantities are directly proportional. So we can write, which means that these two ratios are also equal. So we can write 360 divided by p equal to pi r square by what we have to find. Let us take it s. Let us take it as x. So x equal to pi r square into p, pi r square into p divided by 360. This is the area of the sector, which means the shaded area. So now let us find what they have given, what they have asked. The area of the sector of a circle with radius 4 cm. So OA equal to OB equal to 4 cm and of angle 30 degrees. So this angle equal to 30 degrees. Okay, now so let us find the for 360 degrees. So for 360 degrees, we have the area is for pi r square, which is pi r square, which is equal to 16 into for 360 degrees, we have pi r square. So this is also equal to pi r square. They have given r equal to 4 cm. So 16 pi and pi equal to 3.14 they have given to use. So 16 into 3.14. 16 into 3.14, this is equal to, we'll calculate it later. So they are asking for 30 degrees. 30 degrees equal to how much? This one equal to how much? Now as these two quantities are directly proportional, we can write the area. We can write the ratios. 360 by 30 equal to 16 into 3.14 divided by what we have to find. Let's take it x. So now we have x equal to 30 into 16 into 3.14 whole divided by 360. So now 0 cancel. 3 12 by taking 3. Now over here 4, we have this 3, this is 4, and now 4 into 3 this is equal to 4 into 3.14 whole divided by 3. This is equal to 12.56 by 3. 12.56 whole by 3. This is equal to 4.189. So we can take it as 4.19. So we can write the area of the sector OAB. Sector AOB. So we can write the area of sector AOB equal to this one equal to, we got 4.189 is approximately 4.19 centimeter square. This is the area of AOB. They are also asking also find the area of the corresponding major sector. Okay, now major sector is total area minus this minor sector. Total area minus minor sector. So major sector AOB. Major I'm writing like this. AOB equal to the circle area. We have wrote 16 into 3.14.
Pi r square.
Okay, pi r square minus minor sector area. This is 4.19 centimeter square. Or minus, we can write pi r square. Also, find the area of the corresponding major sector. So the area of major sector is, so this is minor sector AOB. This one is minor sector AOB. So now major sector AOB. Major sector AOB. So this is sector AOB equal to total circle area, which is pi r square minus area of minor sector AOB, minor sector AOB. So now we have pi r square equal to, we have pi r square, which is 16 into 3.14 minus segment minor AOB, minor sector AOB, which is 4.19 centimeter square. 4.19. This one is equal to, we have this value equal to 50.24 minus 4.19 equal to 46.05 centimeter square. This is the area of the major sector AOB, and this one is the minor sector AOB. Find the area of the segment AYB. So what is the area of the segment AYB? It is, so segment AYB equal to the sector AOB, area of sector AOB minus this one minus the area of triangle AOB, area of triangle AOB. Now let's find the area of this sector AOB. If radius of the circle is 21 centimeter and the corresponding angle AOB is 120 degrees, they have given. So for 360 degrees, we have the area is pi r square, which is also equal to, we have 21 square into pi equal to 22 by 7. Pi equal to 22 by 7, and for 120 degrees we want to find. So now, as these both are directly proportional, the corresponding ratios are equal. 360 divided by 120 equal to 21 square into 22 by 7 is 441 into 22 by 7. 441 into 22 by 7 whole divided by x. We want to find is x. What we want to find is x right now. So x equal to, from this we can write x equal to 441 into 22 by 7, 441 into 22 by 7 into 120 whole divided by 360. So this is the sector area, which is, we can cancel over here 1, and this one is 3. This one we can cancel over to 441, 63. So and 3, 63. 3, this one will be 21. So final x equal to 21 into 22, which is equal to 21 into 22, 462 centimeter square. 462 centimeter square. This is the area of sector AOB. Now we'll find the triangle area AOB. For triangle area AOB equal to, so this is the triangle AOB. Now we can draw, since this is 21 centimeter, AOB is an isosceles triangle. We can draw a perpendicular distance from O. We can draw a perpendicular distance from O to AB, which is the height. O to AB, that is the height. So we can label it 90. We can label this 90, and since it will also bisect the angle AOB, so it will become this angle. So this angle will be equal to 120 by 2, 60 degrees. 60 and 60, 90. This one will be 30. So because these both will be okay. So if this is 90, we have this will bisect the side AB, because AB is the chord of the circle, and we know that the radius is the perpendicular bisector of the circle. So let this point be some C. We have AC equal to BC. AC equal to BC, and we also have OA, OB are ready. So those both are equal. OA equal to OB, and we have angle between those sides is 90. So by SAS congruence, we can write AOC congruent to AOC congruent to BOC. BOC. Now let us label the corresponding equal angles. Angle A of this triangle equal to angle B of this triangle. Angle A of this triangle equal to angle B of this triangle. Angle O of this triangle. Angle O of this triangle equal to angle O of this triangle. So now angle AOC. So angle AOC equal to angle BOC. Angle BOC. Let us label it equal to x. So we can write the sum of those both angles, which is x plus x. Angle AOC plus angle BOC equal to 120. They have given 120, and angle AOC x plus angle BOC x equal to 120. So x equal to 120. We have x equal to 60. X equal to 60. So this angle equal to 60. 60 and 90. By sum of internal angles of a triangle, x equal to 60. And we can use that over there, 60. And we have 60, 90. By sum of internals of an angle of a triangle, we can write this angle equal to 30. That angle equal to 30, then this is also 30. Because those both are equal. And this angle also 60. Now we get 30, 60, 90 triangle. 30, 60, 90 triangle. Okay, 30, 60, 90 triangle. So 30 is to 60 is to 90. The ratio we know already, 1 is to root 3 is to 2.
So, ratio?
The ratio of the sides opposite to these angles. So, and now we have 90 opposite 21. 90 opposite is 21. Then 30 opposite will be 21 by 2. Which means 2p equal to 21. P equal to 21 by 2. Which is the side opposite to angle 30 will be equal to 21 by 2. Which means the altitude OC equal to 21 by 2. OC equal to 21 by 2. Then the side opposite to 60, the length of that side, which is BC will be equal to 21 root 3 by 2. 21 root 3 by 2. And the area of the triangle, area of the triangle AOB equal to half into. Now the height is 21 by 2. The height, which is OC into BC into 2, which is AB is the base. AB. This is the area of the corresponding triangle AOB, which is also equal to half into 21 by 2 into 21 root 3 by 2. We have this 21 root 3 by 2. Okay. This is BC, and AB equal to 2 into BC. So it would be 21 root 3. 21 root 3. So the area of this triangle equal to area of triangle AOB equal to 41 root 3 by 4. 441 root 3 by 4 centimeter square. So now the sector minus this area will be the segment AYB. So segment AYB equal to AOB. We know the sector AOB's area equal to sector AOB we found over here, that is 462 centimeter square. So 462 equal to 462 minus this one, area of the triangle 441 root 3 whole by 4. This is the area of the segment AYB. Centimeter square. Find the area of a sector of a circle with radius 6 centimeter if the angle of the sector is 60 degrees. So they have given the radius is 6 centimeters. So for 360 degrees, pi r square. pi r square, which is also equal to pi into, okay, 6 square 36, 36 into pi, let us take it 22 by 7, 22 by 7. So 36 into 22 by 7. Now we want for 60 degrees. For 60 degrees, we have to find. So as these two quantities are directly proportional, we can write the equal ratios, which are 360 by 60 equal to 36 into 22 by 7 whole divided by what we have to find, the area we have to find, let us take it as x. So x equal to 60 into 36 into 22 by 7 whole divided by 360. So we have 0 0 cancel, 6 36. This one will be 6 and again 6 36 we have 6. So x equal to 132 by 7 centimeter square. X equal to 132 by 7 centimeter square. Find the area of a quadrant of a circle whose circumference is 22 centimeter. So they have given the circumference is 22 centimeter. The circumference of a circle, which is the perimeter of a circle, is equal to the circumference equal to 2 pi r always. 2 pi r. They have given 2 pi r equal to 22. So we get r equal to 22 by 2 pi. R equal to, we have this one equal to 2 to 22, 11. 11 by pi. 11 by pi. We'll simplify it at the last. The quadrant of a circle, which means angle is 90. So for 360 degrees, we'll get this pi r square, which is equal to pi into 11 by 11 square, which is 121 by pi square. And for 90 degrees we have to find. For 90 degrees, how much? As these two quantities are directly proportional, the corresponding ratios are equal. 360 divided by 90 equal to pi into 121 by pi square. We can cancel pi. This one will be pi. So 121 by pi whole divided by x. We will find x. So x equal to, from this we can get x equal to 90 into 121 by pi, 121 by pi whole divided by 360. So by cancelling 0 0 and 9 and 36, so this one will be 4, and pi equal to, let us use 22 by 7. So this value will be equal to 121 into 7 by whole divided by 22, then whole divided by 4. So we can take, so this one will be equal to 121 into 7 whole divided by 88. 121 into 7 whole by 88. Yeah. So 88 we have, by 11 we can cut this both, which is 11, 8 equal to 77 by 8 centimeter square. This is the corresponding area of the sector. 77 by 8 centimeter square. I am writing over here 77 by 8 centimeter square. Find the length of the minute hand of a clock. The length of the minute hand of a clock is 14 centimeter. So the clock has if this is the center of the clock, O, the length of the minute hand, let us imagine that is the radius of that circle is 14 centimeter. So this is 14 centimeter. Find the area swept by the minute hand in 5 minutes. So the clock has 12 parts. Let's take these both parts between 12 and 1. So they are asking, so in the gap between these both is 5 minutes. So they are asking to find the area of this sector. And we know the whole angle is 360 degrees. whole angle is 360 degrees, and the clock has 12 parts like these. So 360 divided by 12. 360 by 12 equal to 30. So corresponding angle equal to 30. Now we have the circle with angle 30 and radius 14. We have to find the sector area. So for 360 degrees, we'll get pi r square. Pi r square, which is equal to 14 square, which is 196 into, let's take 22 by 7. 22 by 7. I'm cutting over here. 7. And this one will be 28. Equal to 28 into 22. Which is also equal to 616. 616 centimeter square. Now for 30 degrees you have to find. For 30 degrees, how much? Yeah. Okay, we have to find x. So as these two quantities are directly proportional, the ratios are equal. 360 by 30 equal to 360 divided by 30 will be equal to 616 by x. 616 divided by x. So x equal to, from this we can write x equal to 30 into 616 whole by 360. Now but we can cut this 0, 0, 3, 12. And we can we directly cut it? Yeah, 12, and over here, no. By 2 I'm doing, okay, by 4 I'm doing 3, and this one 154. 154 by 3. 154 by 3 centimeter square. 154 by 3 centimeter square. A chord of a circle of radius 10 centimeter. Okay, so this is the center of the circle O. The radius 10 centimeter. So this one's A, this one B. The radius is 10 centimeter. 10 centimeter. Subtends a right angle at the center. Find the area of the corresponding minor segment. So the minor segment means they are asking to find the area of the segment AB.
Sure.
They are asking to find this area. They are asking to find this area. So we know the segment, this area of the segment equal to area of sector AOB, area of sector AOB minus A triangle AOB. Area of sector AOB minus area of triangle AOB. We have to find what this equals to. So let's find AOB, sector AOB. They have given 90 degrees. First, have 360 degrees, pi r square, which is equal to 10 square, which is 100 into 20. Okay, they have given to use 3.14. 3.14. And we want for 90 degrees. For 90 degrees, it will be x. So as these two are again directly proportional, we can write the ratios, which is 360 by 90 equal to 100 into 3.14. We can write it as 314 centimeter square. 314 divided by x. So x equal to 90 into 314 whole by 360. 360. So we can cancel zeros, and 9, 36. This one will be 4. So we can cancel these both. We have this one 2 and this one 157. 157 by 2 centimeter square. I am writing in decimal form 78.5 centimeter square. 78.5 centimeter square, and the triangle AOB. Now the triangle AOB, let us draw the altitude from O to AB. So this angle is equal to 90. Then this one, so in previous one, since this is an isosceles triangle, we have proved that this altitude bisects the angle AOB. So we can write directly this one equal to 45. 45, 90. This one is also 45. So again, we got 45, 45, 90 triangle. 45, 45, 90. 45 is to 45 is to 90. So the sides opposite to these angles are in the ratio of 1 is to 1 is to root 2. 1 is to 1 is to root 2. So now we have 90 opposite they have given is 10 centimeter. This one is 10. So 2p equal to 10. 2p, no, root 2p. root 2 p equal to 10. P equal to 10 by root 2. And by rationalizing this, we can get this one's equal to 10 root 2 whole divided by 2, which is, it can cancel this one 5. So we'll get 5 but 5 root 2. This is the p equal to. So the height will, so 45 opposite we have, we label this point D. We label this point D. We'll get BD equal to OD equal to BD equal to OD equal to 5 root 2. 5 root 2. So the area of corresponding AOB, area of triangle AOB, area of triangle AOB equal to half into, what is height? OD into the base AB. AB. So this one is also equal to, you have that value is equal to AOB. Half into OD equal to 5 root 2. 5 root 2 into AB. AB is also equal to, so we have AB equal to AD plus BD. AD plus BD. And we know, so since this is the radius, if we extend this, it will become a radius. Wait. So if we extend this from D, so this one like this, it will become a radius. And AB is a chord. The radius is a perpendicular bisector of the chord. So D is midpoint of AB. So D is midpoint of AB, which means AD equal to BD. What we have is BD equal to, so we have BD equal to, so we have BD, the BD equal to 5 root 2. So 5 root 2 plus 5 root 2, 10 root 2. 10 root 2. This one is equal to, we can cancel this over here, we will get 5. 5 root 2 into 5 root 2. 25 into 2, 50. 50 centimeter square is the AOB. Now the sector AOB, we got 78.5 minus 50. So sector AOB minus triangle AOB equal to 28.5 centimeter square. Which is okay, 78.5 minus 50. 78.5 minus 50 equal to 28.5 centimeter square. 28.5 centimeter square. Okay. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degrees at the center. So this is the center of the circle. Let us label it O, and this is the angle 90. Angle 60 degrees. They have given radius 21 centimeter. So this is 21. Find the length of the arc. So the length of the arc. Similarly, as we found the area of that sector, we can find the length. 360, we have the perimeter, the circumference of the circle, 2 pi r. For 360 degrees, we have 2 pi r. Then now we have to find for 60 degrees. For 60 degrees, it will be 2 pi, it will be more, how much? Now, again, if the angle decreases, then the length also decreases. And angle increases, then the length of the arc also increases. So these two quantities are directly proportional. Now, which means that the areas are also, the ratios are also equal. 360 divided by 60 equal to 2 pi r divided by 2 pi r divided by, what we have to find, let us take it as x. So we have x equal to 2 pi r into 60 divided by 360. 2 pi r into 60 divided by 360. Now we have, where they have given r equal to 21 centimeter. So over here we get x equal to 2 pi r. 2 pi into 21. 2 pi. Okay, let us take pi as 21 by 22 by 7. 22 by 7. 22 by 7 into 60 into 22 by 7. Oh yeah, 22 by 7 into 2 because 2 pi, and r we have 21. 21, this one into 60 whole divided by 360. Whole divided by 360. So we have cancel 0 0 cancel 6 36. We have this one 6. Then we have over here 7, and this one will be 2. 2 2 cancel. So we got the value 22 by 7 into 7, which is equal to cancel 22 centimeter. 22 centimeter. This is the length of the arc. So this is the first one. Now this is first one. Area of the sector formed by the arc. Yeah, this area of the sector they are asking. They are asking the area of the sector. Okay. So for 360 degrees, we'll get the area as pi r square. Pi r square, which is also equal to pi into we have the radius 21 centimeter. 21 centimeter, and for this is 360 degrees. So for 60 degrees,
area.
Yeah, pi into 21. Pi into 21 square. Okay. Pi into 21 square, and for 60 degrees we have to find how much. Yeah, for 60 degrees we have to find how much. So as these two quantities are directly proportional, we can write the ratios, which are 360 divided by 60 equal to pi into 21 square, pi into 21 square divided by pi into 21 square divided by x. So x equal to pi into 21 square into 60 whole by 360. Whole by 360. So cancel 0. This one equal to 6. Then we have pi. Let us take pi as 22 by 7 again. So this one equal to 22 by 7 into 441 whole divided by 6. Whole by 6. So we have 7, 441. We can cancel to get 63. 63, and over here this one 21. If we cancel by 3, 21. This one 2. And if we cancel these both by 2, we'll get over here 11. So we'll get the final value of x equal to 11 into 6 into 21.
6 pi part.
Oh, okay. 11 into 6 undi.
6 pi x lodi.
Oh, okay. Wait. Okay, that's 6x lodi.
Line got differentiation.
Yeah, so 11 into 21, which is 231. 231 centimeter square. So this one I'll write over here. 231 centimeter square. Next, area of the segment formed by the corresponding chord. Okay, so the chord is, let's draw the chord, which is this one. This is the chord. Let's label these points A, B. So we know the area of the segment equal to, area of the segment equal to, they're asking this one. They're asking area of this part. You know this one's area equal to area of sector AOB minus triangle AOB. Area of sector AOB minus area of triangle AOB. So we have area of sector AOB, we already know, which is 231 centimeter square. Area of sector AOB equal to 231 centimeter square. And we want AOB, area of the triangle AOB. Area of triangle AOB, let's draw the height from O to AB. From O to AB. From O to AB, then this one will be 90 degrees. This one 90, and we already know that the altitude will bisect angle AOB to 30 degrees. So this one 30 degrees, this one also 30, and we have 90, 30, this one is 60. This one 60. This one equal to 60, and let us label this point equal to some C. So we have 30, 60, 90 triangle over here. 30, 60, 90. 30 is to 60 is to 90. The angles, the sides opposite to these angles are in the ratio of 1 is to root 3 is to 2. And we have 90 opposite 21 centimeter, which is 2p equal to 21. 2p equal to 21, p equal to 21 by 2. 21 by 2, which means the angle opposite, the side opposite to 30 is OC. OC equal to 21 by 2. OC equal to 21 by 2. And we want another one is OC over BC. BC equal to, so BC is the side opposite to angle 60. And we have P equal to 21 by 2. So 21 root 3 by 2. 21 root 3 by 2. The area of the triangle AOB equal to, area of triangle AOB equal to half into OC into, and we'll get AB. AB. And since AB is the chord, and if we extend OC to the circle, like this, that is the radius and AB is the chord. So the radius is the perpendicular bisector of the chord. We can say AC equal to BC. AC equal to BC. And we know the length of BC. Okay, we know the length of BC. If BC equal to, over here we know 21 root 3 by 2. So this one equal to half into OC, 21 by 2. 21 by 2 into AB equal to 21 root 3. 21 root 3. So we'll get area of triangle AOB equal to, area of the triangle AOB equal to, area of AOB equal to half into 21 by 2. Okay, 441 root 3 by 4. 441 root 3 by 4 centimeter square. So we have the sector area 231. So segment area of segment will be equal to 230. Okay, I'll write over that. 231 minus this area. 231 minus this one will be equal to 231 minus 441 root 3. 441 root 3 by 4 centimeter square. This is the area of the segment. A chord of a circle
No.
A chord of a circle of radius 15 centimeter subtends an angle of 60 degrees at the center. So this is the circle, let the center be O, then this angle equal to 60 degrees. Yeah, the chord, we have to draw the chord. This is the chord. So A, B, and they said this angle, the angle subtended by that chord is 60 degrees, and the radius is 15 centimeter. 15 centimeter. Find the areas of the corresponding minor and major segments of the circle. So we know the area of minor segment is, they are asking first minor segment is this one. So the area of this one equal to sector AOB. We have to find the area of sector AOB for 360 degrees. For 360 degrees, pi r square, which is equal to, use pi equal to 3.14. 3.14 into pi equal to r equal to 15. So 225. And we have to find for 60 degrees. For 60 degrees, x. X. So as these two are directly proportional, we can write the ratios. 360 by 6 by 60 equal to 360 by 60 equal to 3.14 into 225 whole divided by x. So x equal to 60 into 3.14 into 225 whole divided by, this one whole divided by 360. 360. So 0 0 cut, 6 36. This one will be 6. And we have 6. So this one equal to 3.14 into 225 by 6. 3.14 into 225 whole by 6 whole divided by 6. So this is the area of the sector. Now the area of the triangle. So let us draw the height. The height from O to AB. From O to AB, this point be some C. Then this will be equal to 90. Then this OC bisects the angle AOB. So this one will be 30. This is 30. Then this one 60. So 30, 60, 90. 30, 60, 90 triangle. So 30 is to 60 is to 90. The sides opposite to those angles are the ratios of 1 is to root 3 is to 2. So we got 90 opposite equal to 15 centimeter. 2p equal to 15. 2p equal to 15. P equal to 15 by 2. So OC equal to 15 by 2. OC equal to 15 by 2. And we want AC. OC. Oh, sorry, not OC. AC equal to 15 by 2. AC equal to 15 by 2. 15 by 2. OC equal to, the OC is opposite to 60. So it will be 15 root 3 by 2. 15 root 3 whole by 2. So we know that now we can find the area of the triangle. Area of AOB equal to half into OC into AB. And if we extend this to the circle, it is the radius. And the radius is a perpendicular bisector of a chord. So AC equal to BC. And AC equal to BC. So here we can write AC equal to BC. AC we have 15 by 2. So length of AB equal to 15. This is equal to half into OC. 15 root 3 by 2. 15 root 3 by 2 into AB is 15. 15. So we'll get 225 root 3 by 4. This area equal to, so this area equal to 225 root 3 by 4. Area of AOB equal to 225 root 3 by 4. And now we know the sector area minus this area. We'll get the segment area. So 3.14 into 225 by 6 minus 225 root 3. 225 into 1.73 we can use, because they said use root 3 equal to 1.73. We'll get this one equal to, segment area which is sector AOB minus sector AOB, triangle AOB equal to 3.14 into 225 by 6 minus 225 into 1.73 whole by 4
equal to 20.4375.
Okay, 4375
units
centimeter square. So this is the minor segment area. So they are asking to find the major segment also. So the meaning of major segment is the total circle area minus segment AB, circular segment AB. So we know total circle area equal to 3.14 into 225. So total circle area 3.14 into 225 minus, this one is major segment. Major segment equal to 3.14 into 225 minus 20.4375. This is the area of major segment
equal to
686.0625 centimeter square. This is the major segment. Okay. A chord of a circle of radius 12 centimeter subtends an angle of 120 degrees at the center. So the chord of, radius is 12 centimeter, angle 120 degrees. Find the area of the corresponding segment of the circle. So first let us find the area of the sector. Let us take it as sector AOB. The sector AOB. We'll find the, so for 360 degrees, the radius 12 centimeter, pi r square equal to pi equal to 3.14. 3.14 into 144. This is the area, and for how many? 120. 120 degrees. How much? Okay. So as these two quantities are directly proportional, we can write the ratios are equal. So 360 by 120. 360 by 120 equal to 3.14 into 144 whole divided by x. We have to find x. So x equal to 120 into 3.14 into 144 whole by 360. 360. So we can cancel over here. We'll get 12, 36, we have 3. And if we cancel these both, we'll get 46. So x equal to 3.14 into 46. So if we multiply those both, 144 and 56, 84, 644. 150.44. 48. This one is 48. 48. So 150.72. This is equal to 150.72. This one will be equal to 3.14 into 48. 48, which is equal to 151.52. 150.72. 150.72 centimeter square. This is the sector area. Now this is the triangle area. So for the triangle, we have, so for 12 centimeter is the radius. So if we draw the height, the angle the altitude that bisects the angle. Okay. That will be equal to 30. 30, 90. The other angle will be equal to 60. 30, 60, 90. 60 is to 90. 1 is to root 3 is to 2. And 90 opposite is 12 centimeter. So 2p equal to 12. P equal to 6. So we have, if we take that as AB, if we take OB, that OAB is a triangle, then OB equal to OAB as the triangle, then we get, and if we draw the altitude, the midpoint of AB equal to C. If that is C, then okay, BC, the length of BC will be equal to 6. BC equal to 6. And then the other one, which is OC, equal to 6 root 3. So area of AOB equal to half into OC into half into OC into BC. Diagram is indicated. This is the circle. This is the center O, and these are the radii. So these are the radii, and this is the chord. This is this is the altitude. So this is A, B, C. We have area of this one, area equal to half into OC. So we have this angle equal to 60 degrees. Equal to 60 degrees. 120 they have given. Oh, okay. It will drop. Equal to 120. So this one equal to 60. See, BC equal to 6 root 3. OC equal to 6. OC equal to 6. So this one equal to 30. And since this is the radius, this is the chord. The radius is the perpendicular bisector of the chord. So the AB BA. So area of triangle AOB equal to area of triangle AOB, this one equal to half into OC6 into BA, 12 root 3. 12 root 3. So we get this value to 12. This one equal to 6. So it will be 36 root 3. This one equal to 36 root 3. And they ask it to use root 3 equal to 1.75, 1.73. This one equal to 36 into 1.73.
Just a calculation. Abacus.
Multiplication. Just 36. $62.28.
Very nice. Good.
So 62.28.
Equal to.
Okay. 62.28 centimeters.
Required area equal to.
Yeah, required area of this segment AB, segment AB equal to 150.72, 150.72 minus 62.28, 62.28, which is 88.44, 88.44 centimeters square. 88.44 centimeters square is the corresponding segment area. Oh. A horse is tied to a peg at one corner of a square-shaped grass field of side 15 meter by means of a 5 meter long rope. So they have said that this is the rope. The horse is tied to this corner with the rope. So the given rope length is 5 meters. 5 meters, and the grass shape the side of this grass shaped square shaped field is 15. So equal to 15 centimeters. So 15 centimeters. The area of that part of the field in which the horse can graze. So the angle over here, because it is a square grass field, the angle will be equal to 90.
15 meters.
Okay, meters.
Side 15 centimeter unde 5 meter rope pettara.
15 meters. So yeah, so if this is the 90, this is the part that the horse can graze. They are asking to find the sector of the circle which has the chord septence, the angle at the center is 90. So this is the chord. This is the chord, and that whole this is the sector. We have to find that sector. So for 360 degrees, have pi r square. This is equal to r equal to 5 meters. So 25 into pi. So we can, so pi, let us imagine pi equal to 22 by 7. Pi equal to 22 divided by 7.
They ask you to use 3.14.
I'll second part. Okay, fine. Into 3.14. So for 90 degrees we have to find. For 90 degrees we have x. As these two quantities are directly proportional, the ratios are also equal. So 360 divided by 90 equal to 25 into 3.14 divided by x. So x equal to 90 into 25 into 3.14 equal to whole divided by 360. So you can cancel 0, 9 is 36. This will be 4. So 25 into 3.14 is 25. 78.50. 78.50 whole by 4. This one equal to 19.625. 19.625 centimeter square. Meter square.
యూనిట్స్ కేర్ఫుల్ ఉండాలి.
19.625 meter square. Second part, the increase in the grazing area if the rope were 10 meters long instead. So they're asking if the radius is not 5 meters, it is 10 meters, the sector area. So again 360. So for 360, pi r square, which is equal to 10 into 3.14. 10 into 3.14.
Square.
Wait. For 360, pi r square equal to 3.14 into 100. So for 90 degrees, x. As these two are directly proportional, the ratios are equal. So 360 divided by 90 equal to 3.14 into 100 is 314. 314 whole by x. So x equal to 90 into 314 whole by 360. 0 cancel. 9 36. This one is 4. So equal to 78.5. 78.5 meters square. 78.5 meters square. 78.5 meters square. Okay, the increase they are asking, which means the difference of these both. So 78.5 minus
The increase in grazing area is
increase area is area equal to 78.5 minus 19.625. 19.625, which is equal to 58.875 meters square.
good. Right? But we need to call 875, not 875.
Yeah, 875.
58.87. Okay, nice calculation. Right, good.
58.875.
తమ్ముడు దగ్గర బాగా నేర్చుకున్నారు బాగా సార్.
A brooch is made with silver wire in the form of a circle with diameter 35 millimeters. So we have a circle with diameter 35 millimeter. They have used silver wire to make those diameter. The wire is also used in making 5 diameters, which divide the circle into 10 equal sectors. So that wire is also used to make 5 diameters with a length of 35 millimeters with 10 equal sectors as shown in figure. So they have used that wire to make the circumference of that circle and the diameters of that circle. So the total length of the silver wire required. The circumference, which is 2 pi r, the length of wire required. So the length of silver wire, right? Length of wire equal to 2 pi r plus the circumference plus 10 into 2r diameter.
Diameters, any diameters?
10. 5. 5 into 2r, which is equal to 2 pi r is, we have given diameter is 35. 35 pi plus 5 into 2r is 35 into 5. 35 into 5 is so 175. 35 pi. So we can use pi equal to 22 by 7. This is equal to 35 into 22 by 7 plus 175. This is equal to, by cancelling this, 735. We will get 5. 110 plus 175 equal to 285. 285 millimeter. 285 millimeters is the length of the silver wire required. Area of each of the sector of the brooch. Okay, there are 10 sectors and we know the circle area. Okay, we know the circle area, which is area of circle. Area of circle equal to 2 pi r square, which is equal to 22 by 7 into, if diameter is 35, then radius is 35 by 2. 35 by 2. So we can cancel 7.
Every time square much more.
35 square by 2 square. 7 to this, we'll get 5 into 35. 5 into 35, 175. And over here, 2 square, we'll get 2 over here and 11 over here. 11 into 175 by 2. 1925 by 2. 1925 by 2. 1925 by 2 millimeter square. Okay, and now they're asking each sector. For each sector, which means this whole part divided by 10. The area of each sector, right? Area of one sector equal to 1925 by 2 whole by 10. 19.
Total area by 10.
Okay, yeah, total area by 10. Total area whole by 10. Total area by 10. Okay, fine. This is equal to 1925 whole by 2 into 10. 1925 whole by 2 into 10. So we can, okay, 2, and this one 385. 385 by 4. 385 by 4 in the decimal form. Okay. The millimeter square. Millimeter square. Okay.